Welcome you all. I am Dr.S.Amala, Assistant Professor, PG and Research, Department of Chemistry. Let me talk on hybridization. Hybridization is a process in which the orbitals of slightly different energy are mixed together, resulting in the formation of equivalent number of new orbitals of equivalent energy. Various types of hybridizations are discussed in organic molecules such as SP3, SP2, SP. Let me discuss the SP3 hybridization of methane. In methane, carbon forms 4 bonds with 4 hydrogen. So all these bonds are covalent bonds. Atomic number of carbon is 6. The ground state configuration of carbon atom is 1s2, 2s2, 2px1, 2py1. And the excited state configuration of carbon is 1s2, 2s1, 2px1, 2py1 and 2pz1. The number of orbitals involved in the bonding process is 4 and these are 1 2s and 3 2p orbitals. In ground state configuration, there are only 2 unpaired electrons, each in 2px and 2py. Since the covalency depends upon the number of unpaired electrons, the carbon atom is expected to be divalent in its ground state. But in most of the carbon-containing compounds, carbon isn't tetravalent. The tetravalency of carbon can be explained by promoting one of the electron from 2s orbital to the empty 2pz orbital of the same atom, thereby giving 4 singly occupied orbitals. Now, these 4 orbitals are available for chemical bonding. The carbon atom in this state is referred as excited state. Each covalent bond formation, both carbon and hydrogen have to share 1 electron each. Each hydrogen has 1 electron in 1s orbital and the carbon has to utilize 1 2s and 3 2p orbitals. The orbitals involved in the bonding process should have an equal energy. But in carbon, the 2s orbitals is slightly lower in energy than the 3 of the 2p orbitals. With this energy difference, if these orbitals are involved in the bonding process, the resulting bonds would not have equal energy. Therefore, the molecule formed will not have required stability. Therefore, the molecule is referred as unstable. But it has been established that the compound methane is a stable one. The stability is accounted by the process is known as hybridization. That is, before bond formation, the 2s and 2p orbitals of carbon considered to undergo hybridization. These are 1 2s and 3 2p orbitals are mixed together, share their energy equally to form a set of equivalent number of new orbitals of equivalent energy. The newly formed orbitals are called as hybrid orbitals and the process is known as hybridization. Type of hybridization is SP3 as 1 2s and 3 2p orbitals are hybridized. Each SP3 hybrid orbitals contain 1 electron that can overlap with the 1s electron of hydrogen to form CH sigma bond. In the same way, other 3 CH sigma bonds are also formed. As the newly formed hybrid orbitals will have equal energy, the bonds formed will also have equal energy. Therefore, the molecule methane is a stable one. Let me extend my discussion to the SP2 hybridization of ethylene. In ethylene, each carbon forms SP2 hybridization, which involves 1 2s and 2 2p orbitals. So, the number of orbitals involved in the bonding process is 3. The newly formed hybrid orbitals lose the individual identity of s and p orbitals. Hence, these orbitals are referred as SP2 hybrid orbitals. Each carbon in ethylene forms 1 sigma bond and 3 pi bond. The 1 sigma bond is formed by the overlap of sp2 hybrid orbital of 1 carbon with the 1s orbital of hydrogen. The another sigma bond is formed by the overlap of sp2 hybrid orbital of 1 carbon with the sp2 hybrid orbital of another carbon. Finally, the cc pi bond is formed by the lateral overlap of pz orbital of 1 carbon with the unhybridized pz orbital of another carbon. Finally, let me extend my discussion to the sp hybridization of acetylene. In acetylene, each carbon forms sp hybridization, which involves one 2s and one 2p orbital. So the number of orbitals involved in the bonding process is 2. The newly formed hybrid orbitals lose the individual identity of s and p orbitals. Hence, these orbitals are referred as sp hybrid orbitals. Each carbon in acetylene forms 2 sigma bond and 2 pi bond. One sigma bond is formed by the overlap of sp hybrid orbital of one carbon with the 1s orbital of hydrogen. The another sigma bond is formed by the overlap of sp hybrid orbital of one carbon with the sp hybrid orbital of another carbon. The one pi bond is formed by the lateral overlap of unhybridized POI orbital of one carbon with the unhybridized POI orbital of another carbon. The final pi bond is formed by the lateral overlap of unhybridized PZ orbital of one carbon with the unhybridized PZ orbital of another carbon. Thank you for patient listening.